Hello and welcome back. I hope you're all feeling good, relaxed after that session. And now we're moving on to our next session with Michael Dawson. So Michael Dawson is a member of the Red Hat Node.js team, and he's chair of the Node.js Technical Steering Committee. As well as being an active contributor to the Node.js project, he's also contributed to community efforts, including platform support, build infrastructure, and API reference, as well as tools to help the community achieve quality with speed. Michael has also worked on building IBM's Java runtime, building and operating client-facing e-commerce applications, building PKI, and systematic-based crypto solutions. In his spare time, he uses Node.js to automate his home for life and for fun. And we were talking backstage about how I saw Michael about 5 years ago at NodeConf talking about his cabin, which was a small shed that he'd automated, which was absolutely awesome. We will be doing a full Q&A with Michael after the session, so if you have any questions for him, please do use Slido to get those questions in. So over to Michael with real-world Node.js success stories.
Hi, thank you, Katie. And I guess today I'm going to be talking about Node.js success stories, so I'll take it away. Before I get started, a little bit about myself. I guess I already had a good introduction in terms of the work that I'm doing in the community, member of the technical steering committee and very active member of a lot of the working groups. But as the node lead for Red Hat and IBM, it lets me work with a lot of the organizations and groups within the two companies that are actually using Node to deploy Node.js applications, and basically cover a lot of the constituencies that we have in the Node.js space. So before I get started, a little bit about what I'm going to take you through. First of all, I want to talk about some real-world success stories using Node.js within IBM and Red Hat. And then I'm going to go to talk about what I actually realized was a success story within an ecosystem while I was putting together the presentation. I'll talk about some customer success stories. And then finally, I'll give you some thoughts on sharing Node.js experience across two large organizations. So just before I get started looking at those success stories, a few things that I wanted to point out were, we're not just working to help our customers and working with the community to build Node.js. We're actually a major Node.js user internally within Red Hat and IBM. We have over 45 different projects who have a registered dependency, and what that means is that they're either bundling Node.js or using Node.js to the extent that they want to know that they have support if something isn't going right. We have a very active Slack group with over 1,600 members who are continually talking and helping each other with JavaScript and Node questions. We have lots of published packages, and really what I came to see is that in IBM and Red Hat, we have coverage for almost all the constituencies that we came up with working on the next 10 years of Node effort. And that's an effort to look at, what made Node successful in the first 10 years and what we should be doing in the next 10 years to continue to be successful. It's an effort within the Node.js project. And, we came up with a list of constituencies in terms of, all the different groups of people who have sort of a stake in the success of Node.js. And it's interesting that, I think we cover all of those. So let's move on to look at two large Node.js deployments, the IBM Cloud UI and the Weather Company. So the first one is the IBM Cloud UI. If you've ever gone to the IBM Cloud, you're using a very large very large Node.js application. It's microservice-based, and it lets users create, view, and manage all sorts of platform as a service or infrastructure as a service type resources like Kubernetes clusters, virtual servers, bare metal servers, and Cloud Foundry apps and services. And it's built so that it provides services to any of the teams that want to deliver services through the IBM Cloud, so they don't have to reinvent the wheel in terms of things like registration and onboarding, identity and access management, billing, providing documentation. And so it provides a way that we can reuse all of that logic across the different services. So as I said, it's microservice based. There's about 90 microservices that make it up. This was actually a point in time. I suspect there's more today. It's designed for plugins. And actually, we have over 50 different teams who've designed and written plugins to expose their services. So that tells me that, in addition to those 45 teams that have registered dependencies, we probably have at least another 50 teams within IBM who are using Node.js and writing Node.js code. It's, of course, deployed in Kubernetes, and it's a very large Kubernetes deployment in that it's 10 geoload balance clusters deployed around the world. So, very, very large deployment. It wasn't always that way, though. Back in 2014, it was released as a monolithic single-page app. Everything was loaded within that single page, including the CSS, the HTML. It was served from a single Java app, which also provided like all the APIs that you needed, and it was deployed in Cloud Foundry. Unfortunately, that had some downsides. One of them being bad performance. So the heavyweight JavaScript framework that was being used at the time took quite a while to load. There was a lot of communication back and forth using Ajax, and that created bottlenecks. It also caused problems when we wanted to provide new services, in that it was difficult for those teams to integrate new code. We had to push the whole product, even for small product changes. We were getting poor SEO, and really new hires didn't want anything to do with working on the project because it was using technologies that they didn't find fun to use. So this is moving to a cloud native architecture based on microservices brought a lot of really great benefits. The first one being flexibility. The different teams could deploy at their own schedules. Teams could use stacks of their own choosing. They didn't have to wait for each other, and it really allowed a paced migration so that we could move from what we started with to the fully microservice-based architecture over time. We also found that it improved performance significantly. So we ended up with small microservices which were optimized for speed and page size, which was great. And finally, productivity was greatly increased. And not only could we move faster, but it meant we could move faster with less chances of breaking other parts of the product. So we got lots of the great benefits from moving over to a node-based solution using microservices. Now, some of the lessons learned from that success story is that monitoring is critical. Lots and lots of things can go wrong, and root cause determination can be very difficult. Some of the required metrics that we needed to be able to sort of keep on top of things were, the response time and the response codes for every inbound and outbound request, memory usage, CPU usage, and uptime for all the different microservices, and just the general health of the overall system. So when you move to that microservice-based approach, there's a lot more moving pieces, and so you really need the data to be able to figure out and understand what's going on. So the team ended up moving to a metrics gathering approach that relies heavily on Prometheus and OpenTelemetry, which lets us gather, data both on a particular microservice base, but also tracing transactions across the flow of the different microservices. And that really proved to be critical in terms of making sure that we could keep on top of what was going on, drill down when problems were happening, and sort of do an investigation. And so this is one of the reasons why I'm really quite interested in the async local storage work that we're seeing in the community, which we saw Vladimir talk about yesterday, because it's really a key component of making things like OpenTelemetry work well. So it's really good to see that moving forward. The other lesson learned that I wanted to share is that we shouldn't tie the microservices to regions. As I mentioned before, this was very large deployment, deployed across 10 different regions. And you could take an approach where a particular microservice was tied to a particular region. And really what we found is, that's not what you want to do. You want to make sure that microservices in each of the different regions can talk to microservices in the other regions. And that will, position you much better to handle problems when they come up and be able to do failover and all that kind of stuff properly. The next success story I wanted to talk about is the weather company. You may have already used this yourself. This is an application that provides weather for places all across the world. In addition to the app that you can use to check the local weather, which I do all the time. You can also use its APIs, which provides data so that you can do things like outage prediction. You can get signals about. You can get advanced insights of what's going on, and even breaking weather news, so that you can integrate into that sort of the weather aspect into your application and provide value add. And again, this is another large application, all powered by Node.js. Again, truly global application. It supports billions of locations, lots of zip codes, and very internationalized. So 60 languages across 230 different locales. And again, this is a reason why, like when we saw Node 14 came out as the first LTS release that has full ICU data built in, it's great to see that functions like internationalization are being progressed in the community project, so that we can make it easier for these large type deployments to work and be deployed successfully and most easily. In this case, it uses a global infrastructure. Again, in this case, 4 regions, 7 different Kubernetes clusters, over 400 worker nodes, and dozens of services, which may have from 3 to 100 different copies, currently all running in the IBM cloud and serving a very large audience. Again, this wasn't always the way. Back in the old days, it started out as a monolith, and there was a number of problems which are probably going to sound familiar. So performance, it was costing a lot to operate the system that was originally built. It wasn't as stable as we'd like it to be, and developers couldn't move and develop as quickly as they wanted. JavaScript developers, because of course the front end pages were written in JavaScript, so we needed to write in JavaScript, weren't familiar with the back end, which was Drupal and PHP. So we moved to a cloud native architecture using the backends for front ends pattern, decoupling the page front loads. It uses server-side rendering, and it uses Node.js microservices to expose all the APIs that are supported for the application. Some of the benefits we saw included velocity. So again, we hear that using JavaScript on the front end and the back end helps you move faster, and this is a case where that actually proves that out. So we ended up with JavaScript on the back and front end, which was easier for developers to contribute, because it was easier for developers to contribute across the stack. We achieved better stability. Some of the great tooling in the Node ecosystem, things like ESLint, Jest, and so forth, helped us build a good pipeline and a development process that really, resulted in smaller and more reliable deployments, so that the risk of something going wrong was decreased. We also achieve much better performance. Node used in the right context can scale very, very well. And this again showed that we could, develop an application that scaled really well, much, much better than the old application, and could be deployed much more cost effectively. If you're interested, you can actually read more about that by going to this link, where there's a full case study if you want to find out more details. So the next thing I want to talk about is a Node.js success story of an ecosystem. And I started out with a number of customer success stories, but while I was looking at them, I realized it was really more of a success story about the ecosystem, and this is about IBM i. IBM i is a platform which has been around for quite a long time. It's not necessarily used in startups, but it's used in a lot of companies who are doing day-to-day business, so manufacturing, agriculture, all those kinds of businesses. And what they want is a solution where they don't necessarily need to put together a whole bunch of different pieces. So the IBM i platform gives them an integrated solution with a database and all that. And basically, they want to focus on running their business, not building technology, and it's a great fit for that. So a number of years ago, we all know that open source is basically being very, very successful. And the IBM i team and Jesse Gorzinski in particular realized that open source was going to be a key part of the future. So what they did is they moved on to, they actually worked to make Node.js a first-class participant in that ecosystem. They built NPM modules that were needed to access the native features of the platform. So an IDB connector and P connector to talk to the built-in database. iToolkit, which helps you support integration with the other native features like calling RPG, which is the native language, and even COBOL. As well as pulling in some ecosystem packages like Loopback to make pulling in new data easier. And by basically building the infrastructure that the ecosystem needed, they made it really easy for IBMI developers to adopt Node. And it was actually really successful because as we can see that today, in this marketplace survey, over 25% of all IBMI customers actually report using Node.js. And so I look at that as a real success story for the ecosystem. And how did that happen? It happened because the ecosystem looked to Node.js as a piece that would add real value for their customers, put in place the things that it takes to make it a first-class citizen, and then help customers, deploy the applications. And it was very successful in terms of, Node.js being one of the major languages and runtimes which is now used in that ecosystem. Now I'm going to move on to customer success stories, and admittedly, it's only going to be one customer success story because I spent a lot of my time talking about the other aspects, and therefore I only have time to talk about this one. There are quite a few success stories, although we don't have all the customers that we work with because, of course, we need to get the okay from our customers before we can talk about those. So there are a large number of others that I'm aware of, but we can't necessarily share. There's 8 just on the IBMI site itself. So if you want to go read some more details about those particular customer success stories using Node.js, you can go and check it out. The one in particular I was going to take you through is Crass. They create wood products for their customers, and they come along with a very specific requirements. So when they're creating those wood products, they need to make sure that the temperature, the humidity, and all the environmental aspects of when the wood is sort of milled to the requirements meet those requirements. They have a whole bunch of programmable logic controllers, and they wanted to control those to make sure that the environment was as specified. What they did is they pulled in Node-RED, and Node-RED is a great offering. It's another one of the OpenJS Foundation projects built on top of Node.js, and it provides you a graphical interface, a graphical way that lets you build together different components that work together. And using Node-RED, they could pull together the different components, integrate their programmable logic controllers, and come up with a solution which controlled, in an automated way, those environmental factors when they were, actually building the products for the customers. There is a lab later on in the conference, building cloud-native AI-infused web apps with Node-RED. That is going to be given by Nick O'Leary, who's one of the co-creators of Node-RED. And if you get a chance, it would be great to register and see you at that workshop. I do think that there's a waiting list at this point, but it's always worth getting on the waiting list because we may see if we could offer it again at some point in the future. So now that we've talked about some large some success stories, I wanted to take a few minutes to talk and share some experience in terms of sharing experience across IBM and Red Hat. As you can see, we've got some very large nodes. We have people who are working in the Node community. We have a good number of Node Bethany Griggs, who you saw talk the first day. And a number of other people who you've probably run in if you participate in the community. We also have teams who are going out and working with customers like the IBM Cloud Garage. And we have a large number of customers who are deploying OpenShift where people run Node.js applications as well. So how do we actually share all of that knowledge and make sure that we're basically being as efficient as possible? And this kind of leads back to my thought, which is that we want to make sure we innovate where it matters. So innovation is great, but we don't always need to innovate. So we want to pick where we innovate, and we want to follow standard practice for our organization where it doesn't. But the question is, what is standard practice? If I go to NPM, I did this a few weeks ago, and there's like 1,400,000 packages. And for anything that I want to do, I'm sure I can find a bunch of them. So how do I find the one which is going to be, good, and also that if I'm working with an organization that other people have experience with, and we can share those experiences and we can help each other. So, what we did is we brought together the various teams. So basically, teams who are doing large Node.js deployments. our people who are working with external customers, the team who is working with on Node.js itself, the team that I'm on, and basically anybody that we could find in the organizations who are using Node or JavaScript. And we got together to say, okay, let's see how we can agree on a standard practice. A few of the things that I think are important to share on this front is that, I've seen a lot of attempts to kind of standardize something, and that's not what we're trying to do in this case. We're not trying to say, here is a set of things that you have to use. So my first advice is don't make it mandatory. There's often very good reasons to use something other than what that common practice is. Even if 3, 4, 5 groups have already used something within your organization, there's good reasons why somebody might want to use something else. So make it mandatory. The next one is don't claim it's the best. It's, in my mind, what we know best as an organization. So what have we used? What have we had success in production with? Not necessarily that it's the best, it's just that what we've used already and we have those experience. The next recommendation is to base those recommendations on real world experience, not just research. I can go out and I can look and see which packages have the most downloads, but there's nothing like having used them hands-on in the real world, in those large deployments, spread across 10 geographically distributed Kubernetes clusters to figure out what's going to work and actually gain some real experience in terms of what's some good guidance and how to use it. So base your recommendations on real world experience. Of course, involve broad involvement and build consensus because we need to have buy-in. And in the end, in my mind, it's really just about providing the answer to the question, who said, in terms of, if somebody has the question, what do you think I should use to have an answer to that? And that's something that, we find more and more our customers are asking, as well as our internal teams, because, they're focused on innovating, but that doesn't mean innovating throughout the entire stack. They want to innovate in the area that's specific and important to their particular application. So I look at this as building the, what do you think I should use if somebody has that question. If somebody already knows what they want to use, then they probably have good reasons, and we're not trying to convince them otherwise. And just before I end, I just, if you're interested in following our efforts, again, you've seen the IBM is Open video, and Red Hat is also very focused on doing things in the open. So we're doing this in an open repo, and you can follow us along at this NodeShift project within the NodeShift organization. And, if you have any comments, you can let us know.
Okay, well, thank you very much, Michael. I've been told that I've only got time to ask you one question, so I'm going to go with this one. If you had to choose one reason for the IBM I/stroke Node.js ecosystem success, what would it be?
I think it's because that community is actually a lot like the NodeConf community, where when I come back to the conference, that community has a conference, and I've been to it over the last 3 or 4 years. And every time when I come back, it's a lot of the same people. There's a very good relationship between all the people, and Jesse Gorzinski, who's a key part of that community, did a great job of, teaching people about Node.js, the value, and bringing the components to the platform that were necessary to make that a real success. So, but I think it comes back to that community being a really well integrated and tight-knit community that really helped make that a success.
Great. Well, thank you ever so much, Michael. It's been really, really enlightening. Um,
Great.